for a relatively clean source of energy without depleting existing resources. As solar panel efficiency continues to improve, the challenges lie in distributing the generated electricity in a more effective way. Speaking of solar panels, you may wonder about their efficiency. And we realize that sort of mainstream silicon solar cell typically achieve efficiencies of 22% to 24%. And there are also some noticeable advancements that have been made with certain panel reaching impressive levels as high as 35%. However, it is very important to consider the kind of cost associated with this kind of high efficiency panels. That means if you want the higher the efficiency, you also cost you a lot. So this brings us to the kind of critical issue of affordability. Affordability definitely is another key factor, especially for developing countries such as Southeast Asia countries, an industry that have faced limitation in adopting high energy solutions. Therefore, it became crucial to have reasonable priced and easy to install solutions become a necessity. And this is where we need the expertise of our second speaker, thingnario, in managing the kind of medium to large scale solar PV projects, as well as our some more feasible solution provided by our third speaker, thinggreen, to empower different sectors in managing their carbon footprint through the kind of smart sensors. So to wrap up, today's event will be divided into two parts. The first part is keynote, and the second part is panel discussion. And we are honored to have keynote speakers from NextDrive, thingnario, and thinggreen, who will share valuable insight on the strategy and application of APAC's green energy landscape. All right, let's now shift our focus to our keynote presentation. The first presentation titled Challenges and Opportunities of Energy Transition, Practical Applications of Internet of Energy in Taiwan and Japan. Our speaker, Anita Chien, Strategic Planning Manager at NextDrive, will share with us on the significance of energy management as a competitive advantage. In other words, the ability to manage energy now has become a competitive trait. And she would delve into the concept of decentralized energy management, exploring its nature and current trends. And moreover, Anita will also shed light on the concept of energy autonomy for end users and how NextDrive actively supports various stakeholders in embracing that kind of Internet of Energy during Japan's energy transition. And NextDrive, as you all know, is a shining star in Japan's market with its smart energy management solutions. Collaborating closely with top 10 electric power company to showcase their expertise in the Internet of Energy technologies. So first of all, please join me in giving a warm welcome to Anita Chien. Welcome, Anita.
Hello, good morning, everyone. I'm Anita from NextDrive. So today I'm going to tell you about the challenges and opportunities of energy transition, and both maybe in Taiwan and also in Japan. So when we talk about energy transition, what do you think about? If you check the energy transition in Google, just to figure out the meaning of it, the first line that you will encounter probably will be coming from the Wikipedia. It means that the energy transition is actually a structural change in energy system regarding the supply and consumption. It seems like very difficult to understand, but what it means and what it is in the reality that we are facing. Basically, it means that from the traditional way that we always would think about, maybe if we don't have enough energy, we just build a new power plant, or we put more investment into the maintenance for the existing power plant to work better. But that it already turns very unrealistic in nowadays because the investment in maintenance cost for those power plants is quite high, and it's really not sustainable. But also construction of new power plants, if the power plant is using the traditional fossil fuels, is also not according to the global trend. So this way is not working for the moment. But if we think about for those countries that relies heavily on energy import, like in Taiwan or in Japan, the global scarce supply, according to the geopolitical issue and also the result from the climate change, it also wouldn't provide a sustainable method for the countries that are looking for energy import. So in this reality, we think that actually in terms of energy transition, the more important thing is that you have to go into the reality that from the demand side management is actually the key for future. So what we can do on the demand side, first of all, we can build the renewable energy generation. What that means is that whenever the location is needing the energy should be generated on site. So we promote the self-owned renewable energy generation, and also through power purchase agreement, that we can give those end users who doesn't have huge amount of money to make the initial investment, they can still use the renewable energy through the power purchase agreement. But on top of the renewable energy generation, we still think about how to manage the on the demand side for the end users to also participate into the to help the resilience of the whole power grid. So the solution that we come up is actually a virtual power plant. Through the demand response from this demand side, they can participate with the power grid. Whenever the grid is in need, they can send out the residual or even the surplus resources that they have on their site. But also whenever the power grid has too much power, they can use their resources to use more to increase their demand load to the power grid. So that would have a better collaboration with the power grid and also would help the overall resilience of the power grid. So I will go through with our mission, our mission. In NextDrive, we hope to create an Internet of Energy platform, but why we are doing it is because we want to unleash the full potential of those distributed energy resources that's located in each other's home or everyone's company or manufacturers. We can also see those usually we think that they are the demand side resources, but it can still be created more resource to help the power grid. So in reality, it would be transformed into, you can say that it's a virtual power plant as well. So this is what we're trying to do in NextDrive. So we come up with different type of solutions, but on the smallest scale is basically everyone's home. So for households, we would provide zero energy homes to help everyone to manage their solar panel, or if they have home batteries at home. And then from nowadays, more and more people would have electrical vehicles. So we help them to combine all those resources and help them to use their energy better. And if there's someone that has already a smart home appliance in applications at their home, they can also link with our platform so that the smart home application would be working better in considering the energy consumption scenario. And on the larger scale, we would provide corporate renewable energy management tools for the corporates, whether it's a big building or in factories. So for those companies, they probably would be looking for their energy transition goal into renewable energy, or even reaching the 100% using renewable energy. So we help them to manage their energy well, regardless the resource that they are getting the energy from, whether it's from the traditional power plant, or they have their own solar panel on top of their rooftop, or even they buy resources from other channels for renewable energy. So we help them to manage their energy well and making use of each kilowatt hour that they have. And then for those corporate energy transition goals, usually they would talk about the carbon emission. So we would help them to build up the carbon footprint verification. And then for those companies who are not only just looking for using energy well, they are also looking for if there's a major event in the power grid, what they can do to secure their production. So we would help them to invest in large energy storage system. And then they would be able to even go through to build out its own microgrid, so that whenever there's a power grid events, they can function as in islanding mode, so that the production wouldn't be stopped. And on top of that, some people or some partners in the energy market, they would also think about if they have to put the initial investment into this type of energy management, what can they have in terms of return? So we would help them to participate in electricity trading market as well. No matter if it's building up AFC, the huge energy storage containers, or if they want to build up a so-called virtual power plant through aggregating all those distributed energy resources, we can help them to participate into this electric trading market. But also there's another group of companies. They are not looking for those energy management tools, and also they are not looking for trading, but they want to unleash the power of data. So we provide different energy data applications for those companies who want to build up their own service. So these are the solutions that we have in NextDrive. And the structure of NextDrive product is quite simple. It's actually based on IoT technology. So we have our own gateways. This is our gateway, sorry. This is our gateway. It's set up on the site. So through wire or wireless connections, it would link to all the devices that's located in the different site, no matter it's a PV panel, PV power inverter, or it's a smart meter, or even it's an energy storage system. So we link everything through our gateway and then upload all the data to our clouds, and then all the way up to the application side. And then from the application, based on the algorithm that's regarding the demand, real requirement of the clients, whether they want to reach their RE100 goal, or if they want to make sure that they don't breach the contracted capacity signed with the power plant. So we would do a different algorithm at the back of the applications. And then when there's needed, we would also send up the device control command from the application through our cloud and then to our gateway, all the way to the end equipment, so that, for example, the energy storage system would be charged or discharged based on the needs of the client. So this is basically our I would say this is the architecture of our software. So next I'm going to show you some of the cases in terms of energy transition. And this is helping the end clients who are usually the energy consumption consumers. So how they can manage their energy well. So the first one, it would be the most, I would say this is the easiest one and most common one that everybody would know. I've once heard a really interesting metaphor about energy saving. When we are talking about energy management, everyone's first idea is energy saving. And the metaphor I heard is that energy saving is just like losing weight. You have to read the number, you have to know the number every day in order to do something. So for example, in our, this is 100% energy saver initiative that we launched last year in Taiwan. So already now there's already more than 3,000 users are using this service. And we know, based on the feedback from those users, we know that actually by only just looking to the numbers of their energy consumption each day or even each hour, they can reach 1 to 3% energy saving in total. That's in average. But also for those heavy energy consumers, for example, some people, they don't really use gasoline, they don't use gas at home. They don't have gas oven. So the whole house is run on electricity. So for those clients, they are usually the heavy energy consumers. They, based on the numbers that they see, they can actually do something and make change to how they use energy at home. And the highest number that we heard is it reached 30% of total energy saving. So this is quite important. And this one is a case that we launched in Japan, but in this household, it has a vehicle to home solution, but it is based on the vehicle's, I would say, the specification of his vehicle, electricity vehicle. So in this house, the owner has the solar panel on top of its rooftop, and because of the daily routine of the owner is quite regular, but usually in terms of households, everyone would probably have the same daily routine. You wouldn't really change your routine on a daily basis. So it would be easy for them to set up the scheduling of the vehicle to home solution. So for this owner, usually he goes to work at midday, and then the power is generated during midday as well. So he's not using the power at home, but at that time, his vehicle is parked at his yard. So the solar power would be stored in his vehicle. And at night, when he come back from work, when he go back to his home and do his home chores, and then he doesn't really need to use the energy from the power plant. He only uses the energy that's already stored in his vehicle. So for this scenario, he actually already reached net zero house on some of the days, that if the solar panel generation is quite high. And based on the last couple of months, we contact him, and he's told us that usually his monthly electricity bills by this solution is reached to only 200 Japanese yen only. So it's quite impressive. And this one is in a larger scale, and this is for a corporate. So this is our client in Taiwan. He has more than 10 service centers all around Taiwan, but he only just set up one service center as a benchmark. So in this site, we help them to build up the solar panel at top of the rooftop. And then through setting up a set of energy storage system at their site, he actually, for the last year, the annual energy bill is reduced by 20%. If he doesn't have all this equipment, and also if he doesn't have this energy management system, the average electricity price per kilowatt hour would be $5.13 NT dollars in Taiwan. But through all those applications, his unit price for every kilowatt hour that he gets is actually, he only pays 4.31 NT dollars. So it's quite impressive. And then because of the system, we help him to reach higher percentage of renewable energy consumption. What it means is that because on the rooftop, the solar panel is installed, and the power generation would be based on the forecast, based on the weather condition. So whenever there's a huge sun, if it's a really big sunny day, so the energy generation would be quite high. But on the side, it doesn't really have that much consumption. So it means that usually in this type of scenario, you will have residual energy that will send back to the power grid, and which means that the Taiwan Power Company will probably sign a contract with you, and then they can send out this residual energy to some other people, some other users. But for this side, because they want to increase their energy autonomy, they want to build out more and more. They want to build out their own virtual power plant. So they want to use as much as possible the power generated on their own site. So through smart scheduling, and also we basically have our AI running at the back of the algorithm. So we will predict the power generated, and also predict the energy consumption on this site for every 15 minutes period. And then we can determine whether the energy storage system needs to be discharged or charged based on the situation that the site is facing. So this is our, I would say this is our benchmark case in Taiwan. So the last 3 pages are actually talking about energy transition at the base, at the point of view of the energy user. But there are a lot of people that's working in the energy sector as well. For those people who want to participate in the energy sector, our platform actually also unleash the potential for them to participating into this sector and even for them to build up their own service transition. What it means is that, for example, this is one case in Japan as well. This company is actually SL Lab. They are focusing on the smart home appliance. So in the past, their original service is actually providing smart home applications for the users to do automation for their home appliance, like they can set up specific time to turn on the aircon or turn on the heater, and then specific time to turn off those appliances. But usually those smart home applications, you would think that they would give you different type of scenarios, different type of models, whether if you want to see, if you want to have like a theater mode at a home, so then you can set up the automation. So whenever you say theater mode, the system will help you, maybe you turn off the light and also turn on aircon or even turn on the TV. But those type of usage are not related to energy. So when they are doing, when they are switch on and off, or even turn up the volume or turn up the temperature of those appliances, you don't know what's the relationship between those usage with energy. You don't know if this is actually using more energy or not. But with our platform, we also help them to link everything with energy consumption data. So that because our gateway in Japan also supports the universal communication protocol, which is called EchoNet Lite. So in the user, they don't have to set up another set of gateway in order to get all those data. They only need to, on their on their applications, turn off the authentication code for those equipments to be linked to these applications. So for this service provider, they don't have to install any other equipment in order to go get those data. So it's quite easy and fast to be installed, to be launched, to launch this service to their end users. And finally, they can provide a service that's related to energy consumption scenario. So this is actually one type of the service transition for the service provider that's already working in this in the energy sectors. And the next one, this one is quite common in Taiwan as well. So we call that EPC companies, which means it's engineering, procurement, and construction. So those companies, usually they would have contract from those people who want to build up a solar panel. So they have those contracts, and then they build up this equipment, and then they just help them to keep monitoring the performance of the solar panel. But in the end, they would only get the maintenance fee and maintenance cost whenever there's maintenance is needed. But they are also thinking about whether they can turn their business into a more sustainable business and to create long-term consistent income. So through our platform, we also help them to build up a so-called PPA agreement service, so that they still has to install all those solar panels, but they just need to install another set of our gateway. And then through our platform, we provide them different tools to calculate whether the energy is used at the site, or the energy is actually sending back to the grid, or even sending back to the trading market. And then we help them to settle all the numbers so that they can provide not only just the construction service to the owners, they actually turn into a service operator to provide a power purchase agreement, so that the homeowners, they don't have to make the initial investment to build up the solar panel, but they only just has to change who they buy the energy from. So this is the service that we help the EPC companies in Japan to turn into a service provider. And the last one, this one is actually, we work with Toshiba. So Toshiba, you probably would know that their more common business is actually building up a heavy capital investment projects of renewable energy. So they have their hydrogen power plants and also big solar power plants as well. But these are all more or less more centralized power plants. But they also know that, as I mentioned earlier, the future is actually would be coming from the demand side management. So they also want to utilize all those distributed resources that's located in each facility, whether it's a company, a corporate, the buildings, or if it's in each one's home, the household. So they want to expand their service to not just only for the commercial users or for those who want to invest in power plant investment. So they want to also combine all those distributed resources to form, to provide the ancillary service or even participating in the energy trading market, in real-time market, so that they use our platform. So because this application is a home energy management system is quite mature in Japan. So we help them to set up all those applications to the households of their end clients. And then on our tools at the back of the platform, they can manage all those resources quite well. So whenever there's on the trading market, wherever there's a demand from the trading market that they need excess power, they can see on our platform, knowing which households or which companies they actually at that time has residual resources that can be used, so that they can send out the command control signals from our platform directly to the end users software, and then to form to build up a so-called virtual power plant to help the energy market. So, and also because of our system is quite high compatibility, we have a lot of open API tools to link to their system, so they don't really need to build out they don't really need to put a lot of efforts into the software engineering to form this type of solutions. So overall, actually, what we are trying to do in NextDrive is that we build up an Internet of Energy platform, but we hope to link all the households and also all the corporates whenever they have residual resources that can be work together with the power grid. So we hope that we help everyone to build up a resilient power grid that's actually benefit not only for the power grid operators, but also for everyone as well. So this is my sharing today. Thank you so much.
Thank you, Anita, for your insightful sharing, especially those thought-provoking concepts about energy autonomy and smart home. And now let's shift our attention to the vibrant landscape of Taiwan and the wider APAC region, where we explore how software and big data are driving the net zero clean energy transition, particularly in the solar industry. When it comes to managing solar PV stations, one company stands out, thingnario. They oversee an extensive portfolio of over 4,500 solar PV stations across border with a remarkable combined capacity of 2.4 gigawatts. And thingnario has also partnered with renowned energy developer Vanna Energy to manage Taiwan's largest solar PV project. And this impressive project boasts a capacity of 272 megawatts, supplying renewable energy to approximately 90,000 households annually. Now, let's hear from the visionary behind thingnario's success. Mr. Cardy Huang, the CEO of thingnario, will share the key factors that have propelled thingnario into becoming a leading monitoring provider in the energy of AIoT field. And during his presentation, Cardy will address some issues such as leveraging real-time insights, utilizing AI-powered fault detection, etc. Okay, without further ado, let's welcome Cardy Huang. Thank you.
Okay, good morning, everyone. It's really a pleasure to be here to sharing what thingnario is doing and what kind of value we can bring to the market. So here is today's topic is how software and big data is accelerating the net zero clean energy transition. Here is today's agenda. First, I will take the chance to introduce thingnario a little bit. Thingnario key milestones and project with Taiwan power companies. Last year, we have published a white paper, PV System Performance Analysis of Taiwan. Here, I would like to share some insight. Global action to net zeros. Next, I will introduce thingnario offering comprehensive distributed energy platform. Finally, the conclusion. thingnario was founded in 2017 in Taiwan, which is basically a software company with IoT and AI as the core, using SaaS model to provide software service to various industries. And currently, we are committed to energy sectors. Back to 2017, we found that there is a huge technology gap between IT and OT. IT technology, such as big data, cloud, and mobile computing, artificial intelligence have changed people's lives in the past decades. However, those advanced technologies are rarely be adopted into the physical world. That's why thingnario exists, to mitigate the IT technology gap in physical industry, creating software services by combining IT technology and domain knowledge for business innovations. At the beginning, we have explored several different kinds of industries, such as smart manufacturing, renewable energy, and healthcare. We finally decided to concentrate to energy sector because we see a lot of opportunity there. Photon PV OEM, which is the first energy application of thingnario, is a remote monitoring software systems for solar plants. Here are some achievements. The total managed capacity reached 2.4 gigawatts and more than 4,500 solar plants. Now we are the leading software company for PV OEM. And take last year, 2022 as an example. The new installed capacity in Taiwan is around 2 gigawatts, while thingnario Photon accounts for more than 40% of market share. Besides Taiwan, we have brought this market-proven software platforms to the overseas market years ago. Despite the factor of COVID, we still have served 10 countries successfully. We have quite good presence in Southeast regions, especially Thailand and Malaysia. And Japan will be our next key focus, and we will set up a local office and support on this year's. For SaaS model, retention rate is the most important indicator showing that the satisfactions of customers. In the past years, we have reached less than 1% churn rate. So I would say that reliable intelligence, fast response to service, easy to use, are the main reason why we can lead the market in Taiwan. Here are some success stories of rooftop. The first one is China Steel, which is the biggest steel company in Taiwan. They have invested and construct more than hundreds of rooftop solar on their own factories, with total capacity 90 megawatts. Chili's, a famous leasing company in Taiwan and also the largest renewable investors in Taiwan. They own more than 2,000 solar plants with total capacity 800 megawatts, while half of them are monitored by thingnario solution. currently, the largest solar farm in Taiwan is from Vina Energy, which is a very famous international renewable investors with the total capacity 272 megawatt. Thingnario is responsible for all the monitoring stuff, including 32 power substations, high voltage SCADA data exchange, network topology designs, and all the equipment in the central control rooms. As you can see, the giant solar plant is built on the reclaimed land on the seat. By placing PV modules with different colors, that you can see that you can even see a Taiwan shape from those aerial images. Okay, partnership with Taiwan Power Company. With the rapid increase of proportional renewable energy, the diesel distribution system operator of Taipower encountered a serious challenge to stabilize the distribution network. By referring the international best practice, they adapt to build a DERM systems. In Taiwan, its name is DREAMS, Distributed Renewable Energy Advanced Management Systems, for two major purposes. The first one is to real-time monitoring for all distributed renewable sites. The second one is to apply voltage and reactive power control if needed. Not only integrate with all the renewable sites through certified vendors, but also integrate with some important internal system of Taipowers. So in the past years, we cooperate with Taipower to help them to build the dreams and to stabilize the distribution network. And in the meantime, we also learn from a lot of domain knowledge from system operator point of view. The second project we have cooperated with Taipower is about solar energy forecasting services. Now in Taiwan, there are more than 10 gigawatt solar installed already, and the government aims to have 20 gigawatts on 2025. Due to the variable characteristic of solar energy, the dispatch procedure has become more and more challenging. So the forecast of solar energy is the crucial component for these situations. Thingnario is helped to build different deep learning AI models for nowcasting, for short-term forecasting, which is 1 to 4 hours, and for mid-term forecasting, 4 to 72 hours. From various inputs, including solar production big data and weather-related statistics. So the PVFS provides the accurate solar forecasting to Taipower to help them for the day ahead, as well as the intraday dispatch. In the past years, we have collected huge amount of solar big data. We wonder what kind of insight we can learn from those big data. So last year, we have published a PV system performance white paper. The purpose of this white paper, the first one is to show that the overall performance of solar plants of Taiwan. The second is to investigating the actual benefit of a good maintenance work with the good monitor stations. Let's give you some idea about the data. The total data size is more than 300 terabytes with 20 billion data records. And the cloud systems collect and analyze more than 80 million data records per day. The data set we use for this white paper comes from 3,200 PV plants with total capacity 1.5 gigawatt. And regard to the big data analysis, the correctness of data is the most important things. The data we use, the data integrity is over 99.5%. General findings. The average yield production in Taiwan is 1,317 hours, equivalent to 3.61 hours per day. As you can see, that due to the seasonal variations, the average production yield is significantly higher in summer. So in summers, the production yield is more than 4 hours per day, while less than 3 hours in winter. In reality, there are always losses in the PV systems. So there are two types of loss. We call it unrecoverable loss and recoverable loss. Unrecoverable loss is caused by the array, the inverter, and some system characteristic which is inevitable. Recoverable loss, we further divided into two categories: availability loss and performance loss. This chart reveals that OEM actions taken by various teams along with their average recoverable rate. From these figures, the x-axis represents the recoverable loss rate from 0 to 20%. The y-axis represents the plant count managed by the OEM teams. So each circle represents an OEM team. The bigger the circle, the greater the total capacity managed. And you can see that in the past 3 years, several teams were able to maintain the loss rates less than 1%. But you can see that some other teams that not doing very well, and with the recoverable rate more than 5%. Here are some key takeaways. 29,376 kilowatt hours, equivalent to 2.16% of the energy productions, is the average recoverable power loss per megawatt annually. With the fine central monitoring systems and maintenance team can reduce at least 70.2% recoverable loss. 123.6 hours versus 52.1 hours is the recoverable. It's the average downtime per instance to recover between the average and the first quartile, which means that we learned that with the good OEM operations can reduce at least half of the downtime. Global actions to net zero. On 2050, 196 countries adopted Paris Agreement to have the overall goal to limit warming no more than 1.5 degrees Celsius. On 2020, on COP26 climate talk, countries agreed to cut the carbon emissions and reach net zero by 2050. So in order to keep the warming to 1.5 degrees, countries must cut emissions by at least 45% compared to 2010 levels and reach net zero on 2050. On the enterprise side, big techs and enterprise have even more aggressive goal and commitment. Microsoft and Google aim to carbon neutral by 2030s. Apple calls the global supply chain to decarbonize on 2030s. Facebook, Dell, Amazon have similar goal and commitment. In Taiwan, the largest semiconductor manufacturers and also the largest electricity consumers, TSMC, had joined RE100s and set up the goal to utilize 100% of renewable energy on 2050. Asian regions anticipate rapid economic growth in the coming decades, and of course come with the increase in energy consumptions. However, those countries have committed to net zeros on 2050s. Thailand, Vietnam, and Malaysia had a similar goal to achieve carbon neutrality or net zero by 2050s. Japan declared to realize carbon neutrality by 2050s and aim to reduce greenhouse gas emissions by 46% on 2030s. In Taiwan, on 2021, the governments announced to achieve a target of net zero emissions by 2050s, and also publish a plan for this transition on 2022. So in summary, the global net zero trend is inevitable and accelerating. But there are some challenges come with these energy transitions. First, more and more electrical vehicles and distributed energy resources will increase the instability of the grid systems. So the significant upgrade of the grid infrastructure is required to provide more system flexibilities. Third, policy and regulation are the most important things for these transitions. So for the net zero trend, thingnario is concentrating on the software platforms. Here is our offerings, comprehensive distributed energy platform. Here is the ecosystem of the electricity market. There are many three roles. The first one is energy producers. So they invest distributing energy resources and sell electricity and related service to the market. thingnario started from here to help the asset owners and owning operators to do their maintenance work efficiently. As the business and reputation grows, thingnario got the chance to cooperate with grid system operator Taipower to help them build the term system to help the diesel to stabilize the distribution network. 2 years ago, the open electricity market, which is specialized in ancillary service, has established in Taiwan. In the meantime, the demand of carbon reductions and the ESG compliance is growing quickly. So we have expanded our solution offering to the energy prosumer side. Different from the traditional consumers, there will be a lot of distributed resources on the field, such as solar rooftop, energy storage, EV chargers. So there will be a lot of new business model emerge, and will be a lot of opportunity. For example, VPP operators aggregate different distributed energy resources and provide ancillary service to the system operators, ESGSI, and ESCOs to help the corporate to do the carbon footprint verification based on ISO standard. Renewable energy retailers to sell green energy to corporate through wheelings, which is known as CPPPA. thingnario is concentrating on the software platforms which help our partners, including investors, operators, system integrators, and consultants, to expand their business. So I would say that the thingnario AIoT core is our core of the management platforms. So not only integrate with distributed energy resources, including solar, wind, etc. We also integrate with third-party business applications, energy market, and our own AI prediction services. The thingnario AIoT platform is designed as an open architecture which has the ability to integrate with third-party business applications to streamline the end-to-end processes, including such as ERP or CRM. Open energy market is the trend for the net zero. So we have the experience and capability to integrate with system operators, energy trading platform, and renewable energy certificate. So on top of AIoT platform, we have several different kinds of energy applications. The thingnario energy platforms, here is the Photon family, including 2 applications, PVOM and renewable asset management. PVOM is specialized for solar assets to provide the measure value for central monitoring, diagnosis, and analysis by AI, end-to-end work order systems. Renewable asset management centralize all different types of renewable energy, including solar, wind, biomass, hydro, and energy storage, to provide customized and automated billing invoice, as well as all the reporting need. VPP and EMS are 2 new developed applications for VPP operators and ESCO respectively. EMS is designed to help customers to purchase green energy, to do the power consumption reduction and carbon footprint verifications. VPP is the operating platform for ancillary service operators. By aggregating different distributed energy resources, integrate with the market, bidding optimization by AI, and handling all the bidding stuff afterward. So here, I would like to summarize today's presentations. The first, irreversible net zero trend brings a lot of opportunities. Second, intelligent and reliable software platforms plays a key role. Third, AI and big data will revolutionize the way we monitor and control the energy consumption and the entire power system. Thank you.
Thanks again. Thank you, Cardy, for your inspiring ideas. And we see a very clear, the whole picture of the whole ecosystem empowered by AIoT. And also those ideas about help me to rethink the ideas about unrecoverable and recoverable loss of energy. And it's my pleasure to introduce our final speaker, Mr. Cardy Huang, Chairman of Three Green Technology. Cardy will shed light on the crucial role of energy consumption inventory in enhancing industrial transformation. Energy consumption inventory acts like just like a personal trainer for your carbon footprint, allowing businesses and governments and communities to flex their green muscle. And with 3 green smart sensors as a secret weapon, we can measure our progress and assess the impact of our, evaluate the impact of our actions effectively. It helps us conduct comprehensive assessment, reduce carbon emissions, and unlock cost savings while improving operational performance. And 3 Greens utilize smart sensors with auto recharge technology, and this ensures optimal efficiency in capturing energy consumption data and reducing maintenance cost. The sensors definitely empower business to focus on their core operations while effectively managing their carbon footprint. To some degree, 3 Greens energy consumption inventory and smart sensor technology combined with our the former 2 speakers' capability of NextDrive and thingnario form a coercive and comprehensive energy internet ecosystem. So now let me welcome our third speaker, Mr. Curtis Wu. Thank you.
Hi everyone, I'm Curtis in Green. Net zero carbon emission issue is very popular in this year, but it's also the complicated issue. We help our customer to start to do with that. We provide a energy consumption footprint inventory service. So it's easy to manage every power consumption for each devices or process. We all know the development of industries has long-term impact on the environment. It used to be the problem only for polar bear have to be worried about. But since July 2021, European Union declared the mandatory carbon reduction regulation. Environmental costs will be priced to the enterprise itself. So if there is no change, there will be the risk, or there will be the problem of the enterprise survival. That means the cost, the order will be canceled. It will be affect the capital, will affect the business in the enterprise. Or it's getting harder to borrow the money, or it's getting harder to borrow the capital from the bank. How damaging is your product to the environment? That is very important things. So we all know that every product will be checked. How much the carbon emission for every product we need to check from the raw material mining on the earth, transportation to the manufacturer to produce a lot of kinds of product, packing, warehousing, shipping, distribution, and to the user. And also, and in the end of the product, we will be deal with the final disposal to the environment. So every process we need to calculate, and we need to get the data of the carbon emission. But the most important thing is in the manufacturing, because as regarding the gas, water, oil, electricity, the most the carbon emission comes from the electricity. It's about 70% comes from electricity in the manufacturing. So 1 kilowatt is equal to 0.509 kilogram CO2 equivalent in Taiwan this year. So it's a very important thing. So we have to, how to reduce, how to manage. So as regarding electricity level, all the power from the utility company, and high voltage, discrete, lower voltage by transformer. And there is some primary energy consumption. But as regarding before July 2021, maybe we just need to manage. We just maybe need to manage some primary energy consumption. That's enough. But I was talking about there will be checked in more serious. How damaged is your product to the environment? So we need more data in the production line. Every devices and the process as regarding the carbon emission data we need to collect. So the problem with becoming too many devices and equipment that we need to manage. But as regarding the infrastructure or the process, there will be the problem just like a downtime or a power outage and the wiring. It's hard to do that. There will be the common main point in the industry. So there is the alternative solution. It's just like you just hook at any wire, just hook at that. The installation is almost done. And there is a spec, one feature, just like you will see the device sensor don't need the wire to provide the external power because it's with the energy harvesting. So you don't need to change the battery, you don't need to external power. It's easy to achieve the mass deployment to provide the function just like power consumption footprint would be achievement. So when we get the data with the mass deployment from the alternative solution, and then we will transfer the data to the cloud or to a server with the data analysis, with the high frequency or low frequency with the IoT solution. Also, we also need to collect or integrate with different kinds of existing devices, just like a chiller, a water meter, or flow meter, some kind of any devices which it has some kind of RS485 interface, which is the industry standard protocol. So our product portfolio is a wide range. We can detect just like the lighter in the office, and also we can detect the main power in the whole factory. There is, in addition to the electricity parameter, the temperature issue is also we need to watch. Just like sometimes lower the older wire or some screw loose, it will make the overheating. So that will make the fire disaster. So when we get the power usage footprint data, it's easy to get the proportion or power consumption, and which devices or equipment is abnormal. It's easy to get that. And sometimes some equipment or devices in the factory would happen about the three phases unbalanced. It will cause some fire disaster, some kind of risk. Because we get the comprehensive data, so it's easy to get the utilization rate. Just like it's easy to compare the every devices, the operation behavior, some kind of it's compare about just number 10 and number 4. The utilization rate is almost 100%, but the number 10, the power usage of number 10 is 1.5 times of number 4. So that means it's happened about the normal event. So when we check about the number 10, the bearing is already crooked. That means it's more power consumption happen on the number 10. So we need to predict maintenance to avoid some broken in something where. So we also provide alert or notification management. That means if there is something abnormal or with following we define, that would be send the message to the line, app, or email. In short, our platform will provide some special feature, just like it's easy to manage it, all kind of data or energy management, just like oil, water, gas, electricity, and another one is it could be create the power consumption baseline, because the baseline we follow the ISO 15001, the regulation. So it could be create the baseline. It's very important thing for every factory or every enterprise. If we would like to reduce carbon or control the energy power consumption, create and find out the baseline. It's very important things. We provide a SaaS service, including IoT sensor and the transmission, and with the different kinds of platform, the application. So there is some cases shared here. One of our customers in the international semiconductor company, they have already installed the different kinds of factory, including Taiwan and South Asia. You will see the picture. There is one factory. Its compressor is about 3,000 compressor here, but it's easy to overheating. So you will see how to manage the overheating the issue. You will see they use the temperature sticker. You can see the white line, temperature sticker, but it's not in time. So it has happened about the fire disaster before. So right now it's already used the IoT sensor. When the temperature is over 55 degrees, it sends a warning to maintain the huge devices, some kind of problem. And also they have the more power consumption data in the whole factory. The advantage is improve the yield rate 1% and save the energy about 8%. One of our customers from Japan, they have just like they have the cooling water pump. It's already over 10 years. So it will happen about the extra power usage. So in our platform, it's easy to check how much extra power usage on a platform. So I think it's a very important thing. If the information is not enough, it's hard to manage. So as regarding the information, they will know how to do that. They took a troubleshooting and replacing the key components, make the power consumption reduced to the normal. And there is another issue same as our most customers, just like how to manage the contract capacity. If most of the customers, it's happened about the over the contract capacity. We just know maybe we need to upgrade the power contract capacity. But if we have the comprehensive data, it's easy to know. It's just over the power consumption. It's just maybe a Monday or a Tuesday. So if we have enough the power consumption footprint data, I think it's easy to cut peak and feel the valley. Another one case is one of our customers, they provide a high quality ceramic sintering to TSMC, UMC, something like an international semiconductor company. So it's regarding the use cases, it's about optimization, process optimization. You will see there two process, 2 weeks of process cycle. By the end of the process cycle, you will see it's reheating, but it's not necessary. That will make the happen about the extra power, and also make the quality defect. So, as regarding the information, they will know how to change the parameter. So, it's improved this abnormal situation and save the extra power usage and respect the quality effect. We have some customers from semiconductor company and traditional manufacturing sector. Also, we have some smart building in whatever in Taiwan and Southeast Asia. So just like in Taiwan and Southeast Asia, we have some channel partner to approach the potential customers. So there has been some enterprise need to the first priority to do that, just like textile, petrochemical, cement, electronics, paper, etc. Or if your product need to sell to the Europe, it also need to have the claim to provide a report or carbon emission. And sometimes, if your customer just like in international global company, you will need to be required and ask some kind of carbon emission inventory. And last one, if your contract capacity is over 800 kilowatt, the government has already watching you. So I think it's very effective with the IoT energy consumption management. It's the basis of the meet customer required. It's also the basis of reducing the carbon emission. Also the basis of improving your competitiveness. So let's start to do with that to maintain the environment together from this year. Thank you.
Thank you, Mr. Curtis Wu. Before we move on to our panel, please stay tuned. We will be, while our staff is managing the chair, I would give you a short introduction about our panel as we explore the critical topic of prioritizing energy efficiency in the Asia Pacific. Let's take a moment to reflect on the immense significance of this conversation. The APAC region is home to 5 of the largest emitters in the world. So it plays a vital, pivotal role in global efforts to achieve a green energy transition and reach net zero emissions. APAC is probably responsible for approximately 45% of global greenhouse gas emissions. So it's also crucial to recognize that energy efficiency improvement alone is not enough. While energy efficiency play a vital role, a comprehensive approach that encompasses the entire electric supply chain that advocates collaborations of the ecosystem is necessary to make significant progresses in carbon reductions. All right, so I'm delighted to welcome back Anita, Cardy, and Curtis to share their expertise in our following panel discussion. Please join us. So welcome, Anita. Please be seated here. And Cardy. Okay, please be seated here. And Curtis, this is here. Okay, so you all have your microphone, okay. Well, to begin with our panel, I will start from a more general questions. My first question is for Cardy. It's evident that the thingnario has excellent opportunity for collaboration, especially with those medium and large-scale energy developers. So based on your experience, could you share any significant challenges and opportunities you observe or you encounter in a green energy transformation in Asia Pacific or in Taiwan? Any highlights about opportunities and challenges that you would like to share with us?
Okay, as you can see that because the net zero trend is inevitable, so there will be more and more renewable energy be installed all over the world, in Taiwan and in Asia Pacific regions is the same. And we got the chance to cooperate with those medium-sized and big investors, and they are quite excited to explore, to expand their portfolio all over the world. Like the very big investor, Vina Energy, I mentioned that the headquarters is actually in Singapore, and they have maybe more than 5 gigawatt portfolio all over the world. And the challenge they are facing that is, I would say that is the central management. Because they will invest more and more renewable energy with different type in different countries and regions. And every regions, they have their regulations for the grid connected and regulation compliance. So they are looking for a centralized platform to manage all their portfolios across all countries and different energy type, such as wind and solar, which these two are the mandatory parts. So actually we see that a lot of opportunity. For example, toward the net zeros, the proportion of renewable has been maybe, I would say that maybe 4 times or 5 times in the coming 5 years. So the opportunity is there and the challenge is all there. So that we think that our offering can provide such kind of solution for them to centralize all the portfolio, to provide some intelligence features, and also provide some controllable features for them to handle, to make sure that the asset is secured and produce the returns as they expected.
Okay. How about Curtis? I've noticed that your partnership spanning Malaysia, Indonesia, Thailand, and South Korea, Taiwan. How do you look at these kind of opportunities and challenges in Asia Pacific?
Okay, as regarding the question, I think just what I was talking about in the bridge, the development of the industry has a long-term impact on the environment. So, and also since the July 2021, the European Union announced, declare the mandatory carbon reduction
Yes.
regulation.
Yeah, exactly.
And yeah, so everyone need to start to take care about it, this issue. But as what I know, there are a lot of enterprise don't know how to do that. And so, but they don't have much time to hesitate. I think there are three aspects they have to face. First, it's just, I was talking about from government, the pressure from government. There is some more and more regulation to strict the how to use the energy, how to optimize to effective to use. Just like the enterprise, which the contract capacity over 800 kilowatt, they have already watched from government. That's the first one. Second, the second project is from the customer. Every enterprise is one of the chain, supply chain, right? So they have all of them have the customer. The customer has already claimed or requested about the carbon emission because they provided some key component or material to the customer. The customer need to have the inventory or about the carbon emission, right? So it's already claimed something like that. The second, the pressure. Third is some customers will is already sell the product to the European Union, so they also need to get the report or carbon emission from the international certification, right? Just like ISO 14067, something like that. That's their issue.
Okay. So let me move on the question to Anita. What's your observation for like Japan's market? And then scenario, like Cardy mentioned that based on their experience, there's some clients that need that kind of centralized platform. But from what I know, NextDrive is also advocating for decentralized, that kind of type. I understand both kinds of mechanisms are equally important. So how do you look at this?
Well, basically, I think that both centralized and also distributed ones, they must need to work together because in the end of the day, everyone is connected to the central power grid. So I think that the development of the technology development of both sides are quite important. It's just that maybe thingnario for the time being is more focused on the centralized one, and for NextDrive we are more focusing on the distributed one. But I think we can find a way to collaborate because at the end of the day, as I mentioned, everyone's linked to the power grid, the same power grid, but everyone already knows that, especially in Japan, based on the huge earthquake and tsunami event, they know that they can no longer rely on the resources that's provided by the power plant. They have to build up something that's work better for their own use. So whenever they need power, they have to find a way to generate on their site. And also, when we are talking about energy management, we cannot just think about energy saving, because at the end of the day, you have to use electricity. So if without electricity, you cannot even use your cell phone. And I think that's would be a really big problem for everyone. So at the end of the day, we are helping them through our Internet of Energy platform. And when we help, we want to advocate for everyone who wants to use energy. They have to manage their energy well. And then whether they are thinking about making some investment to maybe install the energy equipment, or they can just do something by monitoring the equipment, like what 3Green is providing, that they can still know for each kilowatt hour, how can make the best use of it. And I think that's quite important. And I would say that this is actually a challenge, but also at the same time an opportunity for all the energy users in Japan and Taiwan.
Definitely, challenges means opportunities. My next question is for Cardy. Let's further talk about the solution itself. So based on, I've heard that the method of the AIoT or the kind of solutions you just elaborate, and I'm quite curious about how your products address the kind of mitigate the kind of common pain points in the industry from your perspective. And also, I know the kind of ready to install the kind of sensor is quite impressive. And then especially I've noticed there are many cases that maybe in one factories you install maybe hundreds of the kind of smart sensors. So could you elaborate a bit more on your product and solutions?
Yeah, as what I was talking about in the past, in the two past year, there has been a significant change on the environment. So I think there are two main issues in the world, apart from the mandatory the carbon reduction regulation. That's first one. And second is there has been a substantial increase in the global energy resource and the raw material prices. I think these 2 points will cause the environment to change a lot. So therefore, it's essential to assess the energy power consumption and identify the energy saving potential. And also, we need to deploy the energy saving measures, some kind of that. So that means all the data will need to require to integrate the energy management, right? So that would be the challenge about the infrastructure for every enterprise, just like downtime and power outages and the wiring. So it's hard to do that. So as regarding the characteristics of 3Green's system service, just I was talking about in the brief. When the process or the infrastructure, you don't need to shut down your power. You don't need to power off. And also no rewiring. So it's easy to mass deployment for everywhere. So it can be achieved. I think power outage and the wiring, something like or downtime, it's it's a common pain point in the industry right now. So 3Greens, I believe we could solve this or overcome this kind of problem. Yeah.
Before moving on to Cardy, I'm gonna ask Anita first. So let's look at like Japan's market again. So from your experience, observation, how do you think how NextDrive contributing to the whole Internet of Energy? And also, I know you've been doing this for many, many years, but could you sort of like highlight one or two that more specific one for us? And how do you think about your product in addressing that kind of pain points?
Yeah, I think when you talk about energy applications, that first of all, you would think about how I can get all the data from the equipment on the site. And as just Curtis just mentioned, that usually when we are trying to set up a smart meter, it would be quite important to, we probably would need to cut off the electricity so that the technicians can just set up the smart meter. But to cut up the electricity, one is already quite a huge pain point for those corporate users because they cannot shut down their production whenever. So usually when we need to do those type of installation, we have to set up a schedule with the factories to know that if they're having annual maintenance day, so that they already have to shut out the power, and then on that day, the same day, we can set up all the equipment as well. But that's one thing, the pain point that we are also facing. So we are quite looking forward to collaborate with Curtis as well. But another pain point would be, as I just mentioned, the connection with all those different type of equipment. And this is actually a pain point in terms of Internet of Technology as well, the IoT. So for all those different equipments, they would come up with their own communication protocol, whether it's CAN bus, Modbus, or Bluetooth, or even in Japan, they have the EchoNet Lite. So how to integrate all those equipments that's running on different type of telecommunication protocol is actually a key in Japan and also in Taiwan as well. And I think this is quite common in Southeast Asia as well. But because of the technology, I would say technology strength in Taiwan, that we know how to integrate things. So that's why we have a huge R&D engineers in Taiwan based, and that's dedicated to improve the integration with all those different type of equipments, and then how to get all those data up to our gateway. And then from our gateway with its edge computing power to get all those data up to our cloud. And then also would have a better management tools for those end devices, and which is connected to which gateways, and then those gateways which are connected to which accounts. And the management of this account, device, and gateway are quite important. And I think based on our, I would say that in Taiwan's software development strength, that's quite a huge advantage when we are entering the Japanese market. And that's why something that the Japanese market, the customers that we have in Japanese market, they look actually already surveyed all the solutions that I can find in Japan. And then later they notice that in terms of integration, there's no one better, no country better to seek the solutions from Taiwan. So that's why we have the connection with Japan.
All right, thank you. And Cardy, I know Scenario is a leading player in the solar monitoring sector. Do you have different observations or different takes on such? And also, what's your solutions, products? Do you have one or more, two more like highlights to elaborate and to share with us how they address that kind of pain point?
For our energy application, we start from the produce side, especially solars. And as I mentioned previously, that they are looking for essential platforms. Here I'd like to address that. I say that centralized is quite different meanings with the distributed, because we all believe that the whole energy, the power system will be distributed.
Okay, sure.
No, without doubt. But you know that there are a lot of distributed resources connected to the power system. So for the investor point of view, they have a lot of assets. They want to
Yes.
centralize to monitor them together. But the power system will be decentralized. I think there's no
Yes.
doubt.
Okay.
Yeah, and for the investor or the oil operator, they are looking for a smarter or intelligent solution for them to help them to make sure that their investment. And as I mentioned, that we found that when we jump into these sectors, we found that a lot of challenge. And the IT technology has really been adapted to that world. I would say that in Taiwan, maybe 6 years ago, some customers are very surprised that we can use just a mobile phone for all the installation and
Wow.
receive the notification from that. If there are errors within that our asset, they are quite surprised. But from our point of view, it's quite mature because once the smartphone has changed people's life. So that we think that we can provide such kind of solution for them to make their operation more smoothly. This from the producer side. I mean the solar, the investor and operators. And because there are a lot of rooftop solar. So in that case, we have the chance to talk with the corporate who buying the electricity from the rooftop. So they, as that Anita and Cardy say, that there are a lot of demand from the enterprise or the consumer side. They want to buy the green energy. They want to do the carbon footprint verifications because of maybe through the C-band import tax or government requirements. So because we serve our customer, which is operators, to help the corporate to buying the energy. So they also have other requests because our partner, they also want to expand their service offerings. So they always, for example, in Malaysia, in Thailand, our EPC partner, they construct a solar plant for their clients. They also help them to do the carbon footprint verifications, to do the energy savings, to buy more and more renewable certificate. So we got a chance to cooperate with our partners to expand our offerings, to help them to expand their, to provide more service to their customers.
Thank you. So Anita, I noticed that along the way it's been impressive to see NextDrive actively collaborating with various sectors in different countries. So do you have anything to share with us and how this kind of collaboration make a practical impact on the whole ecosystem?
Well, I think it will all come back to, in my slides, that we are talking about energy transition or service transition. So for the end users, we provide the opportunity for them to go to meet their energy transition goals. So that by utilizing our platform and then to know how to make the better use of each kilowatt hour that they get. This is the one thing that we would provide for the end customers. And that's why those end customers are trying to contact us to get a solution. But also at the meantime, I think the most important thing is that we are not only just serving for the end clients, we also are helping everyone that's working in the energy market. So that no matter if you don't have any knowledge of how to link all the data to a platform, how to utilize the data, and then we can give you a platform that you can, if you have the engineer that can do more software engineering, then you can use the data up from our platform and then make to create new service. So for example, like in our slides, that for those smart home providers, they already have their own team providing the smart home applications for each users. But how can they combine this usage with the energy consumption scenario? That's something that they never think about. But also maybe in the past they think about that, but they don't have the solution to link both sides. So that's why when we provide this type of platform, for them they can actually transfer their service from the pure automation of the home appliance to actually giving the end users more beneficial way to also utilize the energy even better. And that's one thing. And then for the next thing, as Cardy just mentioned, that for those EPC companies, they are already in this sector, but they can only get the profit from construction and also the maintenance. But how can they provide more service that's related to solar power panel and also that's meeting the end client's use? So that's why we also provide this type of tool for those EPC companies. In the end, they can turn into a service provider, not just only a cost structure. So that's something that we want to let everyone who wants to participate in the energy sector, they can look at our platform and then had a chance to make a big, maybe a service transition as well.
Certainly, somehow that's sort of digital empowerment as well. What about Curtis? Curtis, I've noticed that you have a lot of collaboration with second generation enterprises in Taiwan's technology industry. So based on your experience, do you have anything to share with us about how you guys collaborate together and kind of co-create to help with this kind of energy internet and that kind of energy ecosystem?
Okay. When any kind of enterprise have the plan to achieve carbon narrow transformation, it's generally they need 4 external resources. First is international certificate, because any kind of the carbon emission data, you need to qualify it by third party in an international unit. And second, they need some kind of consultant firms, because international certificate units, and they don't have some kind of guidance to help you how to achieve the certificate. So it's always need some kind of a consultant firm to help them, just like including training or define the working process, and even arrange the data or about the report, and to get a certificate in the end. And third is just like a IT solution provider. Actually, thingnario it provides this kind of service. So when the consultant firm to help to arrange to help any kind of enterprise to collect the data or some kind of consultant, most of the enterprise as regarding the data, including gas, water, oil, electricity, is insufficient. It's not enough. So IT provider solution need to help them to get a comprehension data. Yeah. Third, if the enterprise have already comprehension data, it's easy to clear understanding how to improve and how to reduce the carbon emission. I think it is very important things. And also determine the amount of green energy they have to purchase for offsetting. Yeah. So thingnario we also have the form alliance with different kinds of partners, just like international certificate unit, ARFANO, which is from French, and cooperates with some consultant firm and the green energy company. So we have the whole solution to help our customer for a transformation to a net zero carbon emission. This kind of achievement. Yeah.
So what about Cardy? What, from your perspective, what is the key to collaboration? And do you have any example, sort of like highlight how do you bridge the gap between different different players in the past, or any specific examples that illustrate the ideas of co-creation for a better energy internet?
I said that in the beginning we start from Taiwan, because when we're doing the energy internet, we need a partners, because as we are software companies, we don't have domain knowledge. At the beginning, we even don't know how electricity is produced. So we have cooperate and discuss with some partners that are familiar with the electricity systems, with the renewable energy system. So at the beginning, we heavily visit those partners to talk with them, to know that what is their pain point. And I got some pain point I mentioned previously. And because we are aimed to have become an outstanding software company specializing in energy sector. So I would say that there are three components. The first one is cloud. The second one is IoT. The third one is AIs. So we try to cooperate with those domain experts to build our systems. And I'll take a little time to elaborate more about the cloud. The concept is quite common for most of the people. But when we're talking about the energy sectors, that we believe that there will be millions or 10 million devices on the system. So I think from day one, we designed our systems in scalable architectures that aim to have more than millions devices, maybe smart meters, maybe from inverters, maybe from different sensings on the power system to collect into the systems. So in the past 3 years, even in Taiwan or in Southeast region, we found that a lot of big companies, they want to invest their own systems. It's quite common. And I think that you can do it. But we also have several examples that in the beginning it works, but maybe 2 or 3 years, once the devices in the producer side or in the consumer side become more and more, the system gets some troubles. So that's why some of the big clients come back to us, because they're not the expert is quite different. So they choose to cooperate with us. And when talking about the IoT, it means that for us, it means that they collect the data from physical device to the IT world. And in the past year, we have integrates more than hundreds of devices, including inverter and different kind of smart meters. But we learned that integrate is only the first step, because we found that the physical sensors they will send some, we call it funny data to the cloud. So we have to build a robust system to filter out those invalid data. And from our research on the white paper, we found that there are almost 1% of invalid data is transmitted back to the cloud. And the second one is the unstable. I would say the instability of the internet connection, because for the renewable sites, there are a lot of sites, it's far away from the city. So the communication infrastructure is still a challenge. So we have to provide some kind of solutions that can store locally when the internet is down. That's the IoT part. I would mention that it is two challenge. We are cooperate with our partners. The third one is, we'll say that the AI, because after discuss with our partners, we develop several kind of fault detections or predictive maintenance features, especially for solar plants, to help them to do the maintenance work in a very efficient way. And we also provide the solar forecasting service to Taipower to help them. And I believe that in the future that the power system will be distributed, decarbonized, and intelligence. So AI should be the engines to collect, to analyze, to optimize the whole power system, to make it, I would say that autonomy ways to go for the future of power systems.
Thank you. As we are approaching the conclusion of our panel discussion, I have last question for all you three. Could you all share us what exactly, do you have any milestone or goal for the next 1 to 3 years? First, I'm gonna ask Curtis. So what sort of like key objective that 3Greens has set for the next 1 to 3 years? Or if you have any concluding thoughts, you could also share with us.
Yeah, as regarding the three, within the 3 years, actually we have already accumulated some successful experience within the semiconductor industry and traditional manufacturing sector, or some smart building market. So we are thinking about how to expand our capability in order to serve a lot of more and more potential customers. So we will have the fundraising this year to get more resource and try to have some kind of market talent or R&D talent to upgrade our company. And also within 3 years, we plan to execute an IPO within 3 years to try to get more resource from capital market, and it would be serve some kind of Southeast Asia and more country which they need as our service.
That sounds very promising. And what about Cardy? What do you plan to do in thingnario?
Okay, current thingnario is leading PV monitoring software in Taiwan, account for more than 40% of market share for the new installations. And we expand our solution offering about the solar to the Southeast region and also Japan this year. And we expect for the APAC regions, we also expect we can be the leader for the next 3 years for the renewable energy management. So on the perspective of the capacity, currently we manage 2.5 gigawatt already. And we expect 3 years later, we will manage more than 10 gigawatt over the world, and half of the capacities come from outside Taiwan. And for the renewable type, we not only want to handle solar, but also expand those renewable type to different like wind, biomass, hydro, and energy storage. That is the renewable energy part, which is focused on the prosumer side. And we will keep working with Taipower to help them to build more advanced system to handle the transition or the energy transition to net zero. And currently we are working on some kind of EV projects, because you know that there are more and more electrical vehicles. There will be also a huge impact for the grid. So Taipower is also planning for the futures how to manage those variable consumption parts like EV in an efficient way. So we are discussing with them and help them. And that's the way where we will go to help the Taiwan toward the net zero transitions. And the prosumer side that I have mentioned that we have 2 new development applications. One is for the EMS to help customers to buy more green energy and also the virtual power plants. And because Taiwan has this kind of market, but it's still behind to the world like Japan's. So we expect ourselves in next 3 years, we can be the software platform leaders in Taiwan for these 2 eras and have some pilot projects outside Taiwan. That's our roadmap and some targets for the next 3 years.
Well, I'm sure you definitely have that kind of ability to achieve it. And what about Anita? What are the short-term and long-term goals for NextDrive?
I think that when we talk about energy sectors, there are actually two things that are quite important. One is time, and the other is actually timing. So as in our experience in Japan, we also spend quite a lot of time doing like pilot project with all those end clients. And then, but in the next 1 to 3 years, because of what we've already experienced in the past in Japan, we already see that there are more and more energy service providers. They know how to use our platform and then also do their own service transition into providing different type of service that's using the electricity data. So to form a new application for those end users. And we hope to also keep broadening our exposures in Japan in terms of serving those service providers in order for them to serve the end users. That's what we want to do in Japan. But also in Taiwan, because as Cardy just mentioned, that in Taiwan the regulatory framework is a little bit slower than in Japan. The market scenario is quite different, but based on all those projects that we have in Taiwan and also the knowledge that we gain from contacting and serving the clients in Taiwan, we can also give back some of the market trends and also the experience from Japan back to the Taiwan market, so that for all those Taiwan market, they would know that if they are thinking about participating in these sectors, there are some specific applications or new business models that they can use. So we also want to help them to build up this type of service. And that goal would be the same as in Southeast Asia as well. And we are slowly to build up some partnership with Southeast Asia's companies as well.
Definitely Japan's experience, definitely a good reference to Taipower, Taiwan. Okay, great. Today's discussion on green energy strategy and application in the APAC region has been very thought-provoking, and it is clear that we share a common goal of working towards a more sustainable future. On behalf of Sunrise Media and InnoVEX, we would like to express our heartfelt appreciation to our online and offline followers. A special shout out to Anita, Cardy, and Curtis. Thanks for all your insights today. If you're eager to explore more issues about green energy or other innovation topics, don't hesitate to check out our website at sunrisemedia.com. And this is Chien Ling. I'm signing off now. Stay tuned for more exciting discussion ahead. Have a fantastic day. Thank you. Bye-bye.